Hello everyone, my name is Jonathan and wanted to do a quick overview and demonstration of my Anet A8 3D printer. This is a DIY kit and I have mine installed in an enclosure that is built using two Ikea Lack tables, some printed risers, plexiglass front panel, and I'm using foam board for the sides. I'm gonna try to not ramble and keep this kind of organized. So first thing I'm gonna do is just kind of show you around the printer, what mods I have installed. Then we'll go over Octoprint, the Raspberry Pi, and some of the software features and hardware features of the enclosure. Okay, so as far as the printer goes, it is basically a stock Anet A8 Prusa i3 clone. All the mods that I have done are basically printed mods. I haven't really spent a whole lot of money on different hardware. So first thing is the filament fan is hinged, and that's just to make loading the filament a lot easier. I've got an LED light on the extruder, which makes doing things like bed leveling a lot easier. I've got a printed cable chain just to keep the cables a little bit more organized. A complete printed front panel with Y-belt tensioner. Cable chain on the Y-axis. I've soldered the heat bed wires, got rid of the plug, mine melted pretty much the first day I printed ABS with it. Let's see, if I don't know if the camera's going to pick this up, but my Y-axis bearings are printed, and these actually use 623ZZ roller bearings, so it glides on this rod like a roller coaster. Had very good performance with those versus the standard linear ball bearings. Reprinted the idlers because the ones that came out of the box were warped. This is Leo Nuts' design, basically stock. He added a channel to run the X in-stop wires as well as a X belt tensioner. I've got the fine adjustment Z in-stop, and I've had to replace this Z in-stop switch 2 or 3 times. With as much printing as I do, those switches start to lose their precision. I've also got the Stiffy brace, as it's called. Dramatically helps stiffen up the frame of the printer, as well as Leo's stiffeners here. I've relocated the LCD on mine to out here, so I've got a filler plate, just fills in the buttons in the hole. There's also a brace under the bed that you can't really see. But other than that, the hardware is basically stock. So just some minor performance things. This is also Leo's fan duct. By far the best fan duct I've ever used. So that's it for the printer. Now I'll go over some of the software and hardware features that I've put on the enclosure using Octoprint and the Raspberry Pi. Okay, so for those of you that don't know, Octoprint is a web-based interface using your Raspberry Pi to allow you to control your printer. You can control it using the web interface, Android and iPhone apps, even Apple Watch, Samsung Gear, you name it, there's probably an interface for it. But what this allows you to do is store your G-codes in an easy to use interface, upload them remotely, manage the printer remotely, monitor temperature, monitor your prints, even does a G-code viewer. As it prints, it kind of shows you what that current layer is doing. Terminal access to the serial port coming off the printer. If you have a camera installed like I do, that's a Logitech C270, you can do time lapses, and I'll go ahead and show you a quick time lapse. So here's a time lapse. Looks a little messy. Some prints look better than others. But basically, because Octoprint is actually serving the G-code to the printer, it knows every time a layer change happens. So what you're able to do is capture a snapshot every time the extruder moves up. So stock Raspberry Pi allows you to do basic stuff like you can move the printer around, move it up and down. As you can see, it's actually doing that now. But if you take advantage of the GPIO pins on the Raspberry Pi, you can do some pretty cool things. So this is the power supply, ATX power supply plugin, and this lets me toggle power to the printer. And then I have some custom system commands here. Printer on will turn the power supply on, turn the lights on, get it ready to print. I can manually control the enclosure lights, the extruder light, as well as the manual control of the extruder enclosure fan. And what I can also do is, using the enclosure plugin, I can control the temperature. So I've got two fans. There's an inlet and an outlet. And what this allows me to do is, let's say I wanted to keep the temperature in that enclosure at 75 degrees Fahrenheit. I hit set. Fans come on. And the fans will stay on until 75 degrees is met. I have this set so that whenever I start a PLA print, it automatically changes to 85, and if I do an ABS print, it just stays off. So I'll set that back to 85, and the fan's cut off. So I'll show you the power supply. If I press this, it's going to only turn off the printer. As you can see there, the printer's off, not doing anything. My lights are actually powered by a separate 12-volt power supply. So if I choose this system command here, printer off, it's actually going to turn the lights off as well as the printer. Same thing, I can turn just the printer on, and you can see it there. And Octoprint is going to automatically connect, and once that happens, it's going to display the printer's IP address, the local IP address that's on your network, and that's how you know it is connected and ready. There, rebooted. And there's the IP address. So let's do printer off. And if I choose the custom system command printer on, then it's going to turn the power supply on and turn the lights on. You see how that indicator went from green to gray. The Raspberry Pi will actually sense if the power supply is turned on. And if it is on, this little lightning bolt will turn green. So we'll see that here. I'll click printer on. lightning bolt turns green. And once the Raspberry Pi does its thing, it'll connect. And you also see I've got the temperature readout here. And that is the temperature inside the enclosure. And if you peek back behind here, you'll actually see that blue sensor there. That's a DHT11 temperature sensor. And that's what the Raspberry Pi uses to monitor temperature and humidity inside the enclosure. That sensor to the left there is actually for the Arduino Uno, which is doing the same thing. It's just taking a temperature reading. I'll go over what the Arduino does in just a moment. So on to custom controls. So the enclosure lights and the extruder lights are driven off the pulse width modulation pins on the Raspberry Pi, which means I can essentially dim them. And I'll demonstrate that here. So if I turn the extruder light on high, and there's medium, there's low, and there's off. Same thing with the enclosure lights. There's high, medium, low, and off. Now I've also got some custom buttons set up here for doing my bed leveling routine. If any of you use Simplify 3D, you'll know that Simplify 3D has a very good bed leveler. And what it basically does is just sending out G-code to move the extruder to certain spots on the bed. And my buttons basically do the same thing, although this does it safely. It will raise Z by 5 millimeters, move to the specified areas, and then move Z back down to 0. So I'll show you what that looks like here. So first I'm going to click Safe Home All. And what Safe Home All does is raise Z up a little bit, just in case it doesn't drag on a binder clip that holds my glass on or the bed chain. So I'm going to Home All. And I'm going to press the back right. So you should see Z raise up, move to the back right, and then drop back down. I'll do center front, back left, front left, and dead center. Okay. So that's just an example of some of the custom controls. There's the enclosure lights. So I've got a slider as well as some preset buttons here. One other add-on that I'm using is called Custom G-Code. And what this allows you to do is have G-code execute a bash command. So what I'm using it for is for lighting. Those preset buttons that you saw earlier just send out a G-code, which would be, Octo31, and Octo31 sends a terminal command, GPIO, PWM, pin. Okay, now I'm going to go over some of the hardware. So we'll start up here at the front. This is the stock screen that comes with the printer. I just relocated it to the front. And this is an identical type of screen, just called a 20x4 LCD. And this is hooked up to an Arduino. And it's partly for looks and partly just to display a little bit of information. Still haven't really decided everything I want to do with that. But that is actual voltage. I'm using a voltage divider to read the power supply voltage. And you'll see if I turn the power supply off. There you go, it actually changes. Printer offline, and PSU voltage drops. And if I turn it back on, printer's online, and I've got 12.07-ish volts. The enclosure temperature that you see on this screen is from the little teardrop thermistor back there. I could not figure out a way to have that DHT11 communicate with both the Raspberry Pi and the Arduino. Alright, this is going to look really confusing and like one big cluster. And it is. I have not really done any cable management back here. So this is not finalized as far as what everything's going to look like. But let's go through it one by one and I'll show you what's going on. So we'll start down here. This is a UPS battery backup, and this powers the printer and Octoprint. I've got biggest sealed lead acid I could find to extend the capacity, and this will run the printer with the heat bed running for about 10 to 15 minutes, which it's enough for the brief power interruptions. If I'm home, it gives me time to power up the generator if I need to. Otherwise, hey, the print was probably going to fail anyways for a long power outage. But for those quick little blips, it saved me quite a few from failed prints, just from little momentary dips in power. So then that comes up to this little power block here, and this is for the ATX power supply, and this 12 volt 1 amp is for accessories, and this 5 volt adapter is for the Orange Pi. And yes, I've got a Orange Pi and Raspberry Pi. ATX power supply. The big 12 volt wires all come down to this distribution block and get fed to the heat bed and main power. So that just kind of goes in through this little hole right here. This is a homemade MOSFET for the heat bed. I don't trust the cheap Chinese ones everybody's using. So this is a Texas Instruments 100 amp N-channel MOSFET. Way overkill, but I happen to have one laying around. They only cost about 75 cents, and I know it will handle the load, and I know it's not going to burn my house down. Just an optocoupler taken from an old power supply, a couple resistors. That's all you need to make this thing work. The MOSFET boards everybody are using is way overcomplicated. It's just a switch, folks. This distribution block just for some of the various power taps. These are my transistors for controlling the lights and the fans. So the wires up here are from the Raspberry Pi GPIO pins. It's just the old IDE hard drive cable connected to the Raspberry Pi, and that breaks out the pins that I'm using to monitor the DHT11 temp sensor and control the transistors for lighting and fans. This little board is my voltage divider, which is just some 1K potentiometers, maybe 10K, 10K ohm, or 1K, I don't remember. But anyways, Arduino can only handle a 5 volt input on the analog to digital converter. So to read a 12 volt signal, we have to step that down to under 5 volts and then do some math to figure out what the voltage is. And I've got 3 channels here because I eventually want to measure auxiliary power, main power supply voltage, and I don't know what I'll do with that one, but it's there in case I need it. The Orange Pi is solely there to easily reprogram the Arduino and change features or what I want to put on the screen. I was originally using this Orange Pi as the Octoprint server, but I was having lots of issues with it. Failed prints. I had 18-hour prints that would stop after 17 hours for no reason. Could never figure out what it was. So I got tired of using it and ordered a Raspberry Pi 3. And this thing has worked absolutely flawlessly for the past 3 months, non-stop. So the Orange Pi is just there to run a desktop environment, and it's actually powering the Raspberry Pi through the USB cable. I'm sorry, the Arduino, and makes it easy to program it. So it's got VNC, and I actually remote desktop into this and use that to program the Arduino. So yeah, the Arduino, it's an Arduino Uno R3, and all this is doing is reading that thermistor. All these gray wires are for that LCD screen on the front. And then also this wire is what's monitoring voltage from the power supply. I think that's it for the hardware. Like I said, it's a lot of wires. It looks really complicated, but that's just because I haven't done any cable management. It's really not that complicated. So if you guys have any questions, please let me know. I'll be happy to answer them. And if you need any help setting up something similar to what I've done, I'll do my best to help you out. Hope you enjoyed the video. Thanks. Bye.